Hey everybody, Miller Highlights here. Today we're going to talk about Automotive Diagnostics Basics 101. I had a request to do a video on automotive diagnostic basics. As you can see, I'm a certified master ASC, or I was for many years, and certified master technician on another brand, which I usually don't say on camera because of an NDA document I had to sign years ago. And but you can kind of figure it out from the picture there. When I started with that major corporation, I actually worked on an 800 technical assistance line, and we used to be very effective at diagnosing automotive problems over the phone. Of course, we had full resource of database, historical problems, full line of automotive technical information, manuals, new car features, descriptions, things of that nature. So we were pretty much able to do pretty much anything we want. And plus, being in the engineering department, we were able to actually go ask other engineers. We had a one-off, something really strange. The thing that we would see at the national level, a lot of people would only see maybe once or twice in their career, and we'd see 200-300 of them. So it was quite an experience. But let's get down to diagnostics. It's a process, it's a concept actually. It's not something, it's something that's difficult to teach because it takes a lot of years of school. I mean, I've had between college, factory schools, and things of that nature, I've probably had 10 years of education just in automotive technology itself. But I guess we're going to start off from basics, diagnostics 101. You're always going to verify your complaint. I mean, that's a given, that's number one, because you need to know generally where to go in your diagnosis. Is it a noise? Is it electrical issue? Whatever the case may be. When you identify or verify what the noise is, you need to know related and unrelated characteristics or other issues that are going on with the car. Maybe there's a rattle somewhere else, or the fan comes on somewhere when this condition occurs, and it may not seem it's related, but a lot of times it is related, and a lot of times it's not related. It's just multiple conditions that you have on a vehicle. But once you, let's say if it's a drivability issue, yeah, it doesn't hurt just to run the scanner on these days. In the past, scanners weren't available. There wasn't that information, that kind of information. So you had to kind of make an educated guess. But these days, why not run the scanner on there and see what codes come up, see what issues it finds. A lot of the new scanners are pretty full featured. I did a video on the launch scanner. It tells you a lot. It's not going to tell you everything, but it tells you a lot. But it gives you a direction to start. Once you identify an area or a system that you want to diagnose, my next suggestion, which we used to rely on heavily at the corporate level, was most repair manuals have what's called a general description. Some brands have what they call new car features, new model features. At the beginning of a model year, when they have a new feature, They'll usually have a technical description of that system. In this case here, most repair manuals at the beginning of a section. In this case, we have ABS, anti-lock braking system, and it gives you a general description of how everything operates, what connects to what, you know, the thigh bone connected to the hip bone, that kind of thing. And start there. I mean, once you identify an area, if you know you got an ABS problem, for example, go to the ABS general description and know how that system works on that vehicle. You will save yourself a ton of run around doing needless checks just because you didn't understand how the system operates. And that's really important in the diagnostic process. It's not so much going through the checks, but knowing and understanding how the system operates. And that's where a professional, a lot of years of schooling, factory schools, things of that nature, we pretty much know how the system works, but we'll still revert to the general description or new car features and see what's specific to that model. And then we have a full understanding. So when we see another related issue or symptom that we didn't think was related, and then once we read the description, we might dig into some schematics or something to that effect. They also have not just wiring schematics, they have vacuum schematics, system operation schematics, transmission schematics of components, how they operate. So schematics actually covers a wide range of automotive components. And regardless, I would probably go there next and really have a good understanding as to the direction I'm going on the diagnosis. When it comes to electrical diagnosis, in the past it would be test lights, logic probes, voltmeters, amp meters, volt ohm, actual ohm tests, things of that nature. These days, this is a basic power probe, and it actually takes place of a logic probe, but it uses a transistor LED lights so that you don't, so they're safe around SRS, supplemental restraint systems. And that's kind of where the logic probe kind of started coming in, was supplemental restraints, because a regular test light could potentially deploy the SRS system. So we started using logic probes, so we divert that. But now they've come out with power probes, which is a logic probe. In addition to that, you can apply current, positive or negative. So, and there's also an extra ground to where you can actually test components out of the car, a fan motor, a light bulb, a relay. And even on relays, some relays are powered all the time and you have to supply a ground to activate it, so you can apply the ground. And then some relay systems are powered and always grounded, so you might want to apply power. And so the logic probes are lifesavers. This is a real basic, inexpensive one. You get them on Amazon really cheap, probably 30 bucks, 27 bucks, something to that effect. And for home use, that's plenty. Professional, I'd probably go and spend $300-400, get one of the real high-end power probes that's got volts, ohms, amps, system tests, and it's got a little hook for amp meter and stuff like that. Lifesavers. So if you're not familiar with power probe, look them up, and there's a lot of videos on power probes, but they're lifesavers. Come with real long cords, so you can actually go to the back of the car and test components. Logic probes in the past didn't come with that long a cord, so that's also another advantage of the power probe. It's just very, very handy, very useful. So anyhow, once you actually understand the system operation, you're going to go the next step And you don't want to dive into the hard to reach places when you're doing your test. So you're going to do your basic test. Let's say it's a radiator fan not coming on. You're going to go, first off, probably check the fuses, because that's an easy access point. Secondly, you might go directly to the radiator and test either the fan sensor or maybe the fan itself, and then from there you'd probably go to the relay, because that'd be the next simplest place to go. So those are your basic checks, and a lot of times it's one of those simple areas or locations is going to be your problem. Rarely does it get involved where you're having to dig into wire harnesses, under dashes, and things of that nature. That's kind of rare, actually. The only time you see that is when you see aftermarket radios, aftermarket installations where somebody's actually tampered with the wiring. The other rare occasion is a short. And in terms of electrical shorts, a lot of people refer to a short. There's actually different types of shorts. There's a short to ground, or a grounded circuit. So that means a positive is being fed directly to the ground and shorting out that way. But a true short would actually be, maybe you have two positive wires, and this positive wire is shorting across over to the other positive. So that's actually a true short. And then you have an open circuit where it's just nothing connected. So just want to throw that out there, because a lot of people refer to a short as being a grounded circuit, and that's actually two different things. But anyhow, once you have understood your circuits, you've done the basic, a lot of times they call them split half checks. And basically split half checks means you're going to look in areas that are easy to get to. If you're tearing apart the dash, or tearing apart a fairing, or a shield, or something to that effect, that's really not good proper diagnosis, because you're doing unnecessary work. You want to get it resolved as quick as you can with the least amount of effort into it. And when you're working as a mechanic, you know, you're working on flat rate time, so time is money, and you got to get it fixed. So once you've done that, then you might have to go further, and that's when the power probe is actually going to be really handy, where you can trace down a open, short, grounded circuit in that respect. And in terms of a noise, you know, you're probably going to get a screwdriver or a stethoscope. I've never owned a stethoscope. I've always had long screwdrivers, and just put that up to my ear, the bearings, and believe me, that bearing will just howl like crazy, and let you know where that bearing noise is. A lot of times bearing noises are caused by too tight of a belt, and it actually stresses the bearing and overheats it and damages the bearing. Let's see, some of the other items that are pretty common. That's kind of the gist of basic diagnosis. I mean, I could go into further things, but without an example working on a car, and perhaps I'll do a video down the road of maybe a basic charging system, starting system, and that's actually pretty common, is to show you proper tests. The only other thing I wanted to mention, when it comes to a lot of the multiple codes coming up, or multiple symptoms coming up, or conditions coming up on a vehicle. Maybe you popped up 4 or 5 different codes, and the vehicle runs pretty good, but you got 4 or 5 different codes. The ECUs, or your sensor inputs on your engine control unit, your computer, you have your main power, which is usually 12 volts, but usually your sensors and so forth operate off 5 volts. So it's very low voltage circuits there. And what happens in a lot of, especially foreign cars, I don't know so much about American anymore, but the process that they use to cure the plastic used to be formaldehyde. I don't know if they're still using formaldehyde or not. And that caustic solution will actually create a kind of a film on contacts, relays, and ECU connections over time. There's nothing really harmful about it, but it does have a tendency to put a corrosion layer on relay contacts and ECU contacts, things of that nature. So generally what you would do is get some non-lubricated contact cleaner, go in, clean your ECU terminals and connectors. Sometimes you just have to pull them out, push them back in, that cleans them. But a lot of times that's an easy check. You can go and check all those codes and systems and everything that comes on. Usually the ECU's right there where you can just pop the connectors off, clean them, pop them on, clear your code, see if they come back. A lot of times, not always, but a lot of times they'll go away if you have multiple codes. If you got one persistent, it comes back, okay, you got another issue, you know. When I was in the corporate world, we did a research on failed ECU components. And there's certain models and brands where this is an exception, but in general, well over 90%, I think it was even higher, up around 98, 99% of the ECUs returned under warranty were actually good ECUs, and they were just poor connections. Or another component unrelated to the ECU that was actually causing the problem. So I guess my point is a lot of people oversimplify, or not overcomplicate what their issue is on a vehicle. And simple diagnostics, if you always remember the basics and simple diagnostics, you almost run into it every time, and you save yourself a lot of time, and it's an easy repair, and away you go. So hope that helps with the start. If anybody has got any questions or examples on diagnostics you'd like to see me do a video on, let me know in the comments, and then I'll see if I can do some kind of diagnostic procedure for you, just kind of give you an example. And then again, diagnostic procedures vary from model to model, car to car, issue to issue. So there is a standard procedure, but there is no standard direction that you end up going to do a full diagnosis. Let's put it that way. I've seen a lot of strange stuff. I've seen mice and rats love to eat wiring, you know, and things like that. So I've seen rattlesnakes. Those I avoid, those cars. And I've seen a lot of strange stuff, you know. I've also seen a lot of DIY people actually destroying vehicles almost through their lack of knowledge. And I'm telling you, if you go back to, I can't stress it enough, if you go back to the general overview of the vehicle or system, you'll save yourself a lot of time in diagnosis. It won't fail. It's a learning education on that vehicle. It's a learning education on automotive in general. So barring, or with the exception of actually taking college classes and factory classes, you can learn a lot about the car right there. And so always get a manual that has good general descriptions at the beginning of each section. And you do that, and you make life a lot easier for automotive diagnosis. And that's it. That's your basic automotive diagnosis 101. There you go.